ดีค่ะ
Okay.
Good morning, ladies and gentlemen. We are about to begin our meeting, so please find a seat and make yourself comfortable. Thank you.
Okay. So the opening session will be start very soon. Okay. Honorable guests, the President of Chulalongkorn University, the Vice President of Rajamangala University of Technology Thanyaburi, and the Dean of Faculty of Engineering Chulalongkorn University, ladies and gentlemen. Good morning. It's my pleasure to welcome all of you to 2017 CDIO ASEAN Regional Meetings. I'm Dr. Pisut Phiemanakul from Faculty of Engineering Chulalongkorn University. I'm going to be one of your MCs for today, along with Dr. Dao Suwarnasang Chancharan.
And on behalf of the university, thank you for joining us today. We hope you enjoy the various events and the lectures scheduled for today. This year's CDIO Asian Regional Meeting is organized by Rajamangala University Technology Thanyaburi in cooperation with the Faculty of Engineering at Chulalongkorn University. The objective of the meeting is to provide opportunities for educators to share and discuss education reformations and innovations. RMUTT and the Faculty of Engineering at Chulalongkorn University have been involved with the CDIO initiative since 2014. With the recognition of the importance of education as a major influence and benchmark in a country's development, the CDIO has undertaken initiatives which promote an innovative education framework for producing the next generation of graduates. Present at today's 2017 CDIO regional meeting are educators from various fields, including engineering, science and technology, social science and arts, as well as experts from industries and startup companies, and other representatives throughout Thailand and other Asian countries.
Okay, so it's now time to officially start our 2017 CDIO ASEAN Regional Meeting. On behalf of two universities, we are honored to have Professor Dr. Bandit Uraporn, the President of Chulalongkorn University, that join us for the opening remarks. Please give a big hand and welcome Professor Dr. Bandit Uraporn, please.
Good morning, everyone. Dean of Faculty of Engineering, Assistant to the President of Rajamangala University of Technology Thanyaburi, faculty members and honorable guests. And this morning, on behalf of Chulalongkorn University and on behalf of Faculty of Engineering as well, the place I was a former dean. And I'm delighted and honored to serve as the chair of the opening ceremony of the 2017 CDIO Asian Regional Meeting. We are honored to co-host this event with the Rajamangala University of Technology Thanyaburi as collaborators. This event serves as a platform for exchanging experiences and ideas and to create a network for educational reform under the CDIO framework, which align perfectly with the strategy of our university. I'm confident that today's event will be beneficial to the development and integration of knowledge for innovation creation. We will learn a great deal from each other, and it is now appropriate time I announce the 2017 CDIO Asian Regional Meeting opened, and I wish you all a fruitful discussion and finally leading to an effective execution. Thank you very much.
Thank you very much, our President of Chulalongkorn University for opening remark. Okay, and
For today's lectures, we are pleased to have the honorable keynote speakers and 6 invited speakers from all around the world. The first keynote speaker is Mr. Lim Peng Hun, the Deputy Principal Engineering, Singapore Polytechnic.
the second speaker is Mr. Kan Trakul Hun. He is the Director and Chairman of the Management Advisory Committee from Siam Cement Public Company, Thailand.
The third speaker is Associate Professor Dr. Chi Woo, Department of Electronic Engineering, Chengdu University of Information Technology.
And then, next, Ms. Rakarajan Maharaksami Kishore from Robotics University from India.
And next, Associate Professor Dr. Atiwong Suchato, Vice Dean, Faculty of Engineering, Chulalongkorn University.
And then Dr. Than Nhat Than from Duy University from Vietnam, that he will join and announce for the 2018 CDIO ASEAN regional meetings. Okay.
And before we begin our lectures today, we would like to have the Dean of Faculty of Engineering at Chulalongkorn University. The President of Chulalongkorn University present a token of appreciation to our honorable guest. And after this, we will have a group photo together.
Okay, so maybe may I invite Associate Professor Dr. Atiwong Suchato, the Associate Dean of Faculty of Engineering, to present a token of appreciation. Yes, to the.
So first, the keynote speaker, Mr. Lim Peng Hun. And Associate Professor Dr. Chi Woo from Chengdu University of Information and Technology.
And next, Ms. Rakarajan Maharaksami Kishore from Robotics University, India, please. Maybe she's not arrived yet. Okay, so let's move to the next, please.
So next is Dr. Than Nhat Tran from Vietnam.
But anyway, don't worry, we're gonna keep our token of appreciation for the one who need not choice now. Okay, thank you, Dr. Atiwong Suchato, please.
And before we begin our first talk, I have an announcement. So regarding the Wi-Fi connection, you can connect to the EDU room. I think the system will be ready around 9:30. Yes. And if there is any problem, you can contact the front desk during the break.
Yes.
So let's welcome our first speaker, Mr. Lim Peng Hun, the Deputy Principal Engineering from Singapore Polytechnic. He will be given today's keynote address, Industry Transformation, Challenges and Opportunities for Engineering Education. Please.
Well, good morning. Yes, we're happy to be here. First I would like to take the opportunity to thank the organizer from RMUTT and Faculty of Engineering, Chulalongkorn University, for inviting me to these sessions to share this particular presentation with you. The context of my presentation will be sharing with you how Singapore Polytechnic in particular changing over the years, using CDIO as a framework to support the industry transformation in the country. That will be my context. The outline of my presentation will be as follows. First, I will share a little bit about how Singapore Polytechnic joined, the background to how Singapore Polytechnic joined CDIO, and then followed by describing the industry transformation that is happening in Singapore at the moment, and how Singapore Polytechnic is preparing ourselves to support this next phase of transformation in the country. And finally, I think I would like to just wrap up by looking a little bit forward to what might happen in our journey of educational transformation. Well, joining CDIO. But Singapore Polytechnic is the first polytechnic in Singapore, established in 1954, so we are about 63 years old now. We have 10 academic schools. Yes? Oh, sorry, didn't follow the slide. Well, I was mentioning that my presentation will be in 3 parts. The first part is how we got involved in CDIO. The next is how we are preparing ourselves to support the next phase of economic transformation in Singapore now. And finally, looking forward. And first, what got us involved in CDIO? I think, but before that, Singapore Polytechnic was set up about 63 years ago as the first polytechnic in Singapore, basically to provide manpower training for the country. A bit of history to Singapore economic development. After independence from 1965 to about 1985, that was the first phase of our economic development. Basically, the challenge at that time was high unemployment and also high level of illiteracy. 75% of our population are illiterate. So to help the country start off at that journey, the government adopted 2 very strategic decisions. Number 1 is export-oriented approach, and number 2 is inviting multinational corporations to come to Singapore to invest. In 1965, that was something quite unusual. But anyway, that was a phase 1. It bring the country up well to all the way to 1975. They have full employment in the country after 10 years. In 1985, unfortunately, the first unexpected recession hit Singapore. More unusual is that the world economy was doing well, but Singapore was having problem, 1985. That prompted the government to relook at the policies and so on. So that led us to the second phase of Singapore economic development. Basically, it moved towards a more flexible, service-oriented approach. And since then, under that particular phase of development, the focus is on service industry. And indeed, also there's this big thing about introducing what we call CIE, creativity, innovation, and enterprise, to the economy. It is at that backdrop, Singapore Polytechnic was looking at ways to support that transformation. So in 2004 is where I personally was challenged by my principal at that time to say, look, can you look into a possible education model of the future for the Polytechnic to support this transformation? So I was lucky to look around the world and then to see the chance upon CDIO movement at that time. Some of our founders are here at that time. So my colleague, Ms. P. Sok Hun, was incidental in experimenting with CDIO in her class, and her result was very encouraging. So to give you an example, that she had a class, she grouped them into 10 project groups using CDIO as an approach. At the end of that class, she invited the press to come to see those projects. Out of 10 projects the students exhibit, 7 were picked up to be reported in the newspaper. At that time, annually we have a capstone exhibition every year. And typically, a few hundred projects are out there and you get a few, people get excited. So her result was obviously a very strong data point for me to use when I go to a management to say, look, CDL is something we should seriously consider. And I think I managed to convince everybody to say, look, okay, let's do that. That's the little bit of the history, how well as a group we convinced the Singapore Polytechnic management to say, yeah, let's go CDIO. Very important data point, all right? Okay, the graph basically show up here that before CDIO, we were teaching basically a lot got to do with teach students how to do stuff. We really asked them to think about what to do. So I think with CDIO, we moved towards a two-stage approach where the students are more sensitized to what they should be making. Now, since then, I think we use the CDIO movement to revamp our operations. And as I was preparing this presentation, I looked through some of the archive, and I found this cartoon even, I think it's about maybe 10 years ago somewhere, my colleagues have done that. Oh, Linda. Linda was the one who drew that. Okay, so she's the one, right? Oh, your staff. Okay, anyway, thanks for that. So we do all sort of things to encourage the community to adopt CDIO, right? So, and next we had the opportunity also to share some of this experience with our regional partners. Many of you are here. And that was a good journey, so this is where we are now. But I thought just to stop and have a review of where we are at this point in time, I'd like to show you a short video of a project that a group of our staff and students have done 2 years ago. We respond to a request from a hospital in Singapore. This hospital is a women and children hospital. They have problem with automating or rather they wish to automate their outpatient pharmacy dispensing system. They go for a tender, and the vendor can get worldwide some of the most sophisticated machine for different type of medication, different packaging, but not for bottles. Because I think for medicine for children, very often there are still liquid involved. So to make the system complete, they need to have an automated bottling process, which they could not source for a good one outside in the world. So our team were invited to participate to integrate that into the system. So of course the requirement for this real-life system is very important, no error, zero error. You're talking about dispensing medicine and 24 hours, 7 days a week. Okay, so let me show you a short video to describe how the staff and students have used this CDL to help us to solve this problem. Yes. It's a, Right? Thank you. Yeah. Now, I'd just like to make one small remark. I'm not sure how many of you noticed that. I visited the full deployment subsequently. Actually, one of the very challenging parts is actually when you label and bottle the bottles, there are expiry dates and so on in the original bottle. You can't just cover that. That is very challenging. But anyway, the team solved that problem. I thought that was quite an interesting problem to solve in that. Anyway, let us move on to the next phase of my presentations. Now, second phase of our Singapore economic transformation brought us to about 2010. At that time, we realized that we do have big constraints. And that is where we move into the current phase of our industry transformations. Basically, the big constraint Singapore has is manpower, land, space, and also aging populations. We don't have enough babies. We only have 1.2. That's low. Yeah. Currently, the annual workforce growth rate has slowed to about 3%. And also in the country, 1/3 of our working populations are actually already international or foreign workers. So we can't afford to keep on growing the economy through the participation of international or foreign workers. That's why we are moving into this third phase of our economic development, which is the focus is towards productivity. So to move the country in these directions, the government launched what we call a Skill Future Initiative in 2014. In the Skill Future Initiative, as you can see, there are 3 sections. This group is targeting at the individual. As an individual, the Skill Future Initiative hope to help them to develop their career following their passions, something that they like to do, right? And at the same time, there is also a focus on institutions like the Polytechnic. How can we transform ourselves to better support this phase of the manpower need? And this one. Okay. Anyway, the center box is what I'm talking about. And on the right, in the Skill Future Initiative, we also target at the industry. We like the industry to participate more actively in recognizing the skills that the students and the worker has and reward them accordingly. At the end of the whole thing, we hope that the Singapore populations will develop a lifelong learning mentality. To help in this process, the government even gave each citizen $500 as a training voucher for them to attend any accredited courses run by institution in the country. But many people have not used that yet, including myself. I also have $500, all my colleagues have $500 from the government to attend courses under the Skill Future Initiative. The big part of this transformation also involves what we call an industry transformation map that the government have rolled out. Under the industry transformation map, the belief is that a broad-based approach may not be appropriate. So instead, we would like to have the industry cluster to look into their own need for the future. So there are 23 clusters being set up, out of which 6 of these have been launched as of last year. The idea here is that we would like this cluster of industry, look into innovation and productivity through their own requirement. For example, the group in logistics, they will be introduced to the new technology like additive manufacturing and omni-channel marketing and so on, so that they can position their own businesses accordingly. At the same time, we also like this industry to focus on potentials constraints like land, manpower, and identify them early so that they can work with the government to solve those problems. Under the industry transformation map, there are also ideas like how do you promote e-commerce. So maybe the whole country, we have everybody a locker so that you can buy things and deliver to your locker. That's just an idea. And also, how do you group the trucks that deliver goods from warehouse to the shopping centers instead of individually deliver? Can there be coordinated? That will save the space and also save on the manpower. Those are some of the ideas at the cluster level. As you can see, under the beyond innovation and productivity, there's big parts on the job and skill as well. So the section under job and skill is divided into 4 sections. They look into manpower profile, the skill requirement, career prospect for the people, and also even HR practices to support that particular skill types. All these are being consolidated under what we call a skill framework. The skill framework addresses the need of individuals, companies, and so on. Of course, this is a big thing that we hear a lot yesterday, the Industry 4.0. I thought, personally, I always have fascinations of things like additive manufacturing. I mean, one story I hear about is about 2-3 years ago, the American airline, just this, because additive manufacturing allow you to cut down weights of the plane, right? So while doing that, there was this data point that the American airline, I think they replaced their flight hard copy manual in a cockpit, which is about 15 kg, with iPad, you know, the electronic version. With that change alone, the weight reduced by 15 kg. They save on fuel about $12 million a year. Yeah. Okay, thank you. Yeah. Yeah, okay. So anyway, so I thought there are a lot more potential on this. So the other big components in the Industry 4.0, of course, is robotics. I have a chance to interact with this particular robot from Bosch in the Hannover Fair last year. So basically, when you are away, the robot will move very fast, do their stuff. But if you get closer, it will slow down. And you get closer, if you touch it, the robot will even stop. So it's quite safe. So it's a collaborative robot now. But personally, as I was preparing this presentation, I was attracted to this particular one. This particular robot, this company has been acquired by Google recently, but it's the technology that fascinated me. I'm going to play a short video, less than a minute. What is interesting, if you look at it, the boxes are stacked haphazardly without order. And there are different sizes, different label, and so on. Let's look at how this robot deals with it. The company is called Industry Perceptions, I think, yeah. Anyway, you have an idea. So the robot vision is not just two-dimensional, it has actually the depth as well. So that is something, I think if you trace back, I suppose this is due to the day Nintendo came out with the game and then the Kinects. So you have the accelerometer and then all the chip version of technology accessible by people. So I think this has been deployed to even robotics, right? So at the backdrop of that industry transformation in Singapore and also some of this global development in Industry 4.0, the Polytechnic have to respond. Again, in this case, we ask ourselves, what is the educational model for the future again, this time around, 10 years later. This is our new mandate. Beyond teaching our traditional full-time students in a campus, we actually have to play our role to help our adult trainer to retrain in a big way. So earlier I mentioned about the skill credit training, $500 and so on. Those are money that are given to every individual in Singapore for them to spend to retrain themselves. So we have to support that initiative in the country. So to help us to do that, we will enhance the CDIO model which we have now to include 4 additional components: design thinking, Fat Lab, the skill framework, and also industry value exchange. I'll quickly explain each of these. I think some of these are familiar with you, so I'm not going to. For example, design thinking, I think we have here Dr. Song and so on talk a lot yesterday, so I'm going to skip that. Basically, we introduce this to our students. Okay, the way we put the design thinking and the Fat Lab, they are there to support the design thinking can support the C&D, and the Fab Lab will allow us to support the I&O. So it's quite an elegant model. I quite like this. Yeah. Okay, so this is design thinking process where the students are trained to empathize with the user need and then design through low resolution prototyping, iteration, and so on. Okay. Fat Lab. 3 years ago, we joined the Fat Lab community. After joining that, we actually set up within the Singapore Polytechnic a central Fat Lab plus a group of satellite Fat Lab. And then at the same time, we also encourage our staff to develop their skill by taking part in the Fab Foundations or Fat Lab Academy training program, and of course work on project and join the community. So now we are one of the more than 1,000 Fat Lab in the world. But more importantly is the Professor Neil from MIT who started the Fat Lab, he still runs every year a training program called the Fat Lab, Fab Academy. He personally conducts the lesson for about 6 months while virtual lectures and then practical at your own place. So our Fat Lab is one of the 70 over Fat Lab in the world that conduct this, offer this training. To date, I have about 12 colleagues, that means faculties who have gone through this particular training in the last 2 years. As we speak, this year we have 3 other faculty members going through that. So by the end of this year, we have 15 of them would have completed that Fab Academy diploma program. With that, we hope to provide a platform to develop our students. At the bottom, we actually like to provide a setting where students can experiment and do stuff so long as they are interested. The main thrust here would be the maker space. This is set up in the library. I think some of you have an opportunity to visit the Singapore Poly. You have seen them, they're actually part of the library. It is open to students from more faculties. And then the Fat Lab would be there to support students who are more interested to do serious things. So they can go to the Fat Lab for training program and so on and so forth. And then, if they move on to do more serious industry project, or we call iconic project, they can tap on the expertise in the Fat Lab, not just the equipment. Some of the examples of the projects that are at the different level could be this. At the bottom level, a student can just play with stuff and then they can make stuff. At the highest level, the students can build solar car to compete in the international race. This project We have been participating in the World Solar Challenge since some times ago. It's a biennial event. Last year, 2015, we sent in Sunspec 4. The picture you see is Sunspec 4 to race from Darwin to Adelaide. It completed the race. It didn't come in the first few. But nevertheless, the team learned a lot. And as we speak, my colleagues are building the next car for the race in October this year. So that will be our Sunspec 5. This project, the last project and this particular project are sponsored by the utility, the Singapore Power Utility. They sponsored the building of this whole car because they believe that this is something that they want to support. So the Fat Lab is heavily involved in helping the development of this project. So in a nutshell, through the CDRO and also Design Thinking and Fat Lab, we hope to develop our graduates that are dare to dream and also dare to do. To borrow Professor Song's term yesterday was design thinking and design doing. Maybe that's one way. At the end of the day, we want them to develop the confidence to be able to convert whatever idea that they have to at least a prototypes that can be demonstrated and tested in the market. A quick couple of examples, a recent student project. This particular boy is a first-year student, Julia. Actually, he's selling he's pitching his product to the minister. This is the Ministry of Communications. This boy, actually, he developed a small component sit on top of Arduino board. He managed to sell it to his lecturer, his faculty, so that we buy from him to go outreach to the secondary school to teach students. So because he managed to sell to his lecturers, I told the minister, I said, this boy actually managed to sell his product to his lecturer. So the minister spoke to him, and then he tried to sell it to him too. Anyway, this is another project. A group of students, this particular student actually is a chemical and life science student. He was given a project to take data in his attachment. But he knew about the Fat Lab and what the Fat Lab can do. So when he was doing his attachment, doing the project, he was asked to manually collect data. So he wasn't happy doing that kind of work all the time. That means you go back every half an hour, take data. The researcher asked him to do that. He is not very happy to do that. So he came back to ask for help. So finally, he designed an automated data logger. And then he bring it back to his company and test it and automate the data collections. So he tell his supervisor to say, look, now not even every half an hour. I can do for you 24 hours. I can do for you even weekend. So the professor, the researcher was very happy with his suggestions. This group was built a remote control vehicle taking part of a competition right now somewhere in Indonesia. I think it's, I'm not sure about the city, but they have this competition there. Yesterday, they told, I got an email to say that they're into the second round. So they built this underwater vehicles. And finally, this is the other project that, whereby it's an industry project that the company wanted us to test a wireless charging have. Okay, the third component of how we are trying to enhance our CDRO framework is the skill framework. I talked a little bit about it earlier. So what we do in this case is just to use it to help to validate some of our contents in this case. In the skill framework, they actually spell out the type of job role in a particular industry, and then the kind of functions, and then it break into two types of competency. One is what we call the generic skill competency. The other one is technical skill, which are more discipline specific. Give you an example of how we do this. One of the skill framework that has been published is precision engineering. Using the precision engineering skill industry framework, our colleagues look into this mapping exercise. So for example, we have a set of institutional module. Through this institution module, we know that we have covered such generic competency. And then we have another set of common module. We know it covers another set of competency. And finally, we have some of these competency are covered under a specific course. In this case, mechanical engineering. This is for the generic skill. Then, on the technical skill or the industry-specific skill, an example here would be they map whatever the skill framework spell out with the topics that they teach in the class, and then see whether we map or not, right? So this is an example, and then more. With this particular mapping, it was discovered that the program diploma in mechanical engineering map about 91% of the skill framework for precision engineering. That's the first set of data we got. Using that, we can enhance our own course curriculum as a way forward. Okay? And then since we are in CDIO, I think Helene have kindly do a quick map also for precision engineering, how the generic skill set in the skill framework and also the CDIO framework can be mapped. I think it's quite easy. In fact, there are a lot of overlapping, right? And finally, the fourth element of enhancing our CDIO framework is what I call industry value exchange. The skill framework helps us to look into the what the professional will learn. CDIO basically helps us to look into how the professional learn. And with the two, we hope to have industry relevant course offering to our students. Now, one big component of our partnership with industry is through what we call a enhanced internship. I think this is not something new. It is there all the time. But what we have done in the last couple of years through the Skill Future is to enhance it. What do you mean by enhancing? When we have an enhanced internship scheme, what we have done is that we actually go down to the company to work even closer with the company supervisor, so much so that we expect the company to have a mentor and structure training program for the students who go into the industry. That is the enhancement part. Of course, with that, the students are able to learn better in the industry and bring those learning back to the classroom. So this is the virtual cycle we hope to establish. The enhanced internship refer to the bottom piece here. But what we hope to achieve in the coming years is what we call enterprise solution that we can offer to the company. Now, what do you mean by enterprise solutions? All this while, when we send our students out for internship, we realize occasionally the company benefited from our student attachment. Not just training them, but also solve their problem. And we hope to systematically increase the number of such value exchange. We see potential especially in the sector of small and medium-sized enterprise. As part of the industry transformation process, we need to help this group of SME, small and medium enterprise, to upgrade through the digitization process. And our students are good at that. So they are bringing into the company some of these techniques and also expertise. Like to give an example, a short video about a group of 5 students who have gone through an internship with this company. This is it's not SME, but it's a manufacturing plant. They have a problem of tracking certain things in their productions. So they came for project exhibitions that we had. They identified RFID project that they are interested. So the staff visited them. Eventually, we sent 5 students in. And this is a short video showing what they did inside there.
The project for my internship has much higher expectations. Working at the industry and then studying in school is two different things.
To prepare our students for the engineering workplace in their internship, we in Singapore Polytechnic adopt the Cdio framework to impart the necessary knowledge, skills, and attributes to our students. In the process of imparting our students with such knowledge, we incorporate for the technical modules or subjects learning opportunities so that our students also acquire various personal and interpersonal skills ranging from analytical reasoning, problem solving, to creative and critical thinking skills, and teamwork and communication skills. Through enhanced internship, our students gain experience at the engineering workplace. For example, our students who serve as interns at Sanmina, a multinational corporation which specializes in complete end-to-end solutions for OEMs, contributed towards a project called the Work in Progress or WIP tracking system.
WIP is actually an application on Windows. It's a RFID system which will track a tag connected to the router. So using this WIP program, you can check where is this current tag located at.
So actually the tags actually follow the goods throughout the whole factory, maybe from plant 3 to plant 2, plant 1.
We normally will assign the work activity to the interns based on their strength. So if their strength is more on this computer, I will assign them more on this programming, you see. As this RFID software requires some of this program change based on our user requirement. So if their strength is more on this documentation, I will let them do on this data analysis. Because we gather some of this information from the RFID, then we try to make it more better.
When our students work on this project, they get to experience the full CDIO process in the development of the project, starting from understanding the user's needs and the needed design elements of integrating appropriate hardware and software, to achieving the intended goals, prototyping the system in the implement stage, and finally in the operate stage, deploying it to the plant floor.
I have to learn to stand in the shoes of my user. If I were the user, how would I use this? Is it easy to use? Are some of the buttons and certain input boxes, are they very visible enough? I had to create a web application to display all the information. Firstly, I will test it on my own laptop. I have a copy of the database, which is not connected to the live system. If there's no problem, I will just implement it on the live system.
My role is to test the hardware, which is more making the best use of the routers I have to minimize costs. This is to cover up all the blind spots in the plant.
So even after the implementation, I have to look out for any problems. Sometimes my user or company staff, if they assess it and they see that there is any thing that shouldn't be there, or is there any problem, they will inform my supervisor, or they will inform me.
Through this project, the students are fully immersed in the engineering processes typically found in the workplace.
They are very hardworking. Yes.
Okay, anyway, I think in the interest of time, I'll stop here. But basically, you get an idea. I think the company benefited from the student participation in solving one of their main problems. In fact, the company is so happy that this company have planned beyond Singapore. They are actually wanting to share this system beyond Singapore. So we are encouraged by that. That's why we spend, in fact, Safura, who appeared there, I think is among the audience here. She's here. So I think that's why we make this short video to capture that moment. Okay. Now, that sum up the 4 elements that we introduced to enhance the CDIO framework so that we can support this next phase of our industry transformation. Now, since I started the talk by sharing about our journey in 2004, so I thought moving forward is also good to look back at 2004. Because while I was looking at CDIO, trying to propose that to my management. At that time, I'm also following a very interesting event in the world now. It is, I'm giving you the clue. Some of you may know what it is. So let's see what it is, all right? Mojave Desert is in US, huh?
And we're 30 seconds from history.
What is that?
All right, ladies and gentlemen, boys and girls. Okay, the bot has been ordered to run. The green flag waves. The strobe light is on. The command from the tower is to move. Ladies and gentlemen, Sandstorm.
Sandstorm.
Autonomous vehicle traversing the desert with the goal of keeping our young military personnel
that's
out
the
of
DAPA
harm's
challenge.
way.
The first
Booyah.
autonomous vehicle competitions held 2004. Okay. Anyway, guess what? This is 2004, March. There were 15 cars started. The first car was from CMU, Carnegie Mellon, right? The red team. Within a few hours, all the car failed, drop off. So no car travel beyond, the best car travel 12 kilometers, or 12 miles, I think, around there, right? It's less than 5% of the original journey is about 240 kilometers. So the organizer didn't give up the $1 million, they kept it. So nobody get anything for that race. Okay, that's 2004, March. 18 months later, 2005, October. Let's see what happened. They doubled the price to 2 million. DAPA challenge also, autonomous vehicle. The track, the place they're going through is a different track, also in the desert, but they have 100 overturns, this particular track, including 3 tunnels, passing through 3 tunnels, and also pass through the last stretch, supposed to be what they call the Beer Border Pass, which is something that have a drop on both sides. I think it's quite interesting. I have, again, the short video here. I think you enjoyed it, so I'll play that.
To finish the Grand Challenge, robots must travel on tight desert roads, over dry lake beds, through clouds of dust, under 3 tunnels, and finally, at the 123-mile mark, through the toughest part of the course, Beer Bottle Pass, a narrow, winding road with a mountain wall on one side and a 200-foot cliff on the other. And early on, the big 3 showed why they were the favorites to win this race. Mile after mile, challenge after challenge, Highlander, Stanley, and Sandstorm flawlessly rambled on, all of them hitting GPS waypoints with human-like precision. As the big 3 continued to tick off the miles, others fell by the wayside. At the 9-mile mark, Team Cornell's Spider was the first vehicle to leave the race after hitting the side of the bridge and failing to recover. After 22 miles, Princeton's Prospect 11 and UCLA's Golem 2 could no longer continue. The smaller vehicles in this race all suffered. Early in the race, Rascal from Team Cyanotics suffered a software problem, and at the 7.5-mile mark, Monster Moto, the ATV-based vehicle from Texas, stopped for good. The reliable Ion from Ohio State and the Virginia Tech entries all stopped within 45 miles of the starting point. After a quick start, Team Dad's spinning sensor failed, ending its run at a marathon distance of 26.2 miles. And Alice from Caltech went out in spectacular fashion as it plowed over a safety barrier and up a berm toward a frightened crowd of onlookers. But no injuries, she was stopped in time. But not every robot suffered a dire fate. As the race continued, dark horses were emerging. While the red team robots in Stanley crossed the 70, the 80, and the 90-mile marks, gray team's Cat 5 was surviving the robot wastelands, and Terramax continued to plod along. It was Dexter from Team ENSCO, however, that was really opening some eyes. The speedy, buggy-style robot was not only navigating the course cleanly, but also making up time on the leaders. Although starting the race more than an hour behind the Big Three, early split times indicated that ENSCO's Dexter was actually winning this race. There was a long way to go, but things were looking up for the underdogs. For 2/3 of the Grand Challenge, everything was going as expected, with Highlander in the lead, followed by Stanley, and Sandstorm running a close third. Split times were very close. It was anyone's race. But something was not quite right. After months of successful testing, Red Team programmers were confident of Highlander's abilities and planned a high-speed, aggressive attack strategy for the Grand Challenge. At this point in the course, Highlander should have been 20 minutes ahead of its current pace. There was a problem, a glitch in the system, and it was causing the big red Hummer to limp. At the 102-mile mark, just before heading into the mountain section of the course, Stanley tracked down and passed the crippled Highlander, putting Stanford Racing Team's Volkswagen Touareg into the leader position and effectively ending Highlander's bid for glory. But there was still hope for Red Team. Sandstorm was keeping pace with Stanley, and it was still anyone's race. And that anyone could have been Team ENSCO. After starting 10th out of the gate, Dexter was flying through the course, steadily making up ground. With an average speed over 19 miles an hour, and with accelerations of 40 miles per hour on straightaways, Dexter's chase vehicle was having trouble keeping pace. Stanford may have been leading the pack, but this was a time trial, and halfway through the course, Team ENSCO was winning the race. The Mojave Desert, however, is an unforgiving place if you're a robot. Any one of a million things could go wrong and force an early retirement. For ENSCO, it wasn't a software glitch or a faulty sensor to blame, it was simply a flat tire. After striking a rock, the tire went flat, and the air was let out of Team ENSCO's dream for the $2 million grand prize. With Team ENSCO out of the way, the Stanford Racing Team had a little more breathing room. If Stanley could safely navigate Beer Bottle Pass, it would likely win the DARPA Grand Challenge. To traverse the pass, Stanley must follow several hairpin turns running alongside of a 200-foot drop. The margin for error is small, and for humans, the steep drop is a psychological barrier which makes driving this mountain road a hair-raising experience. But what does stress mean to a robot? It means absolutely nothing. Stanley calmly carves its way around the sharp turns and leaves Beer Bottle Pass without a second thought. With 5 miles to go, Stanley steps on the gas, racing toward the finish line on a dusty desert trail. As Stanley crosses the finish line, the Stanford Racing Team has made its way into the history books.
So I didn't anticipate this to become a race for speed. It's one of the most thrilling races.
Okay, it's a 5-minute video. Still have a lot more, but anyway, I think we have enough, right? Now, this gentleman, of course, the leader, his name is Sebastian Tron. Some of you might recognize him. He was working in Stanford at that time with the director of the AI Research Center. So he's the leader of that team that won. Okay, in that race, 5 cars completed out of 23. Out of 23, 22 cars traveled beyond 12 km. That means beat 18 months ago. So what I keep on emphasizing here is that for 18 months, the tremendous improvement, I think that was something that actually caught me. It's not so much of just they make it, but it is the improvement they made within the 18 months. So 5 teams completed. Now, this gentleman eventually went on to Google to start the autonomous vehicle car in Google, I think. Hey, this is the Google car, you know. As of, I think recently, this Google car has traveled more than 1 million miles tested in the urban setting, no more in the desert, right? And according to what I read, they have 14 accidents, 14. But 13 were human-related. I mean, out of the 14 accidents, 13 was actually somebody else's fault, you know. So it looks like quite scary, yeah? I mean, exciting, but scary in terms of how the machine can do quite well compared to human. I thought the context of the sharing this is also it is this speed of improvement of technology that is, I suppose, when we look into transformation, what is to come in the future is really something that no matter how hard we try, is quite difficult to predict. I think one data point I was reminded time and again is that from the time the Moore's law started in 1950, around the same time, from then till now, it is to the power 27. They are already 27 times. So what it means is that if we start with 5 km per hour traveling at that time, now would be more than 1 million km per hour. So you can literally, at that speed, reach the Mars in a day or less. I don't know, I didn't really count, but that's the kind of speed we are talking about. So what about the next 18 months? I don't know. I mean, that's the kind of things scare me, right? Yeah. So anyway, so we do have a first leg of transformation in the Poly to look in supporting the industry. But I think moving into the future, I personally feel that, you know, it's yet to be really fully discovered. But at best, I came across the work by the Professor Sabina. She has done some good work in this, so I think she said something for future engineering education. There are certain elements there, which I pick it up and put it on this slide. Among others is he talked about engineers have to speak coding. You got to speak like you know, like a software guy. You know, to what extent I don't know. But at the same time, you know, creativity is the gold standard, because a robot can't still cannot be creative, right? But they can take on all routine job, but not the creative part yet. And for the curriculum, I think it has to be a responsive curriculum that we can help individuals to learn new things as we go along. All right. With that, thank you very much. Yeah.
Thank you very much, Mr. Lim Peng Han, for a very interesting and insightful talk. Any questions from the audience? We may have a few minutes.
Yes, Chris.
Yeah, please.
So thank you for the talk and all of the excellent examples and frameworks and so forth. But I was wondering if you could pick one of these challenges associated with Industry 4.0. Which one is the one that causes you the most headache and which is most difficult to work with?
I think it's the artificial intelligence. I mean, if you look at that, the one that is disturbing me a lot is how artificial intelligence have moved. I remember this others, not story, a competition, I think 2015, whereby the the deep learning machine called Analytic pitched against a professional expert radiographer to diagnose lung cancer by looking at CT scan and X-ray. And guess what? The machine won. A radiographer is a profession that after you graduate, you spend 13 years to train to be a good radiographer. That is not a low-level job that we are talking about. And the machine beat the human, right? So that's disturbing to me, right? Okay, of course, so I think because, well, your question, I suppose, is the challenge is there, but how can we deal with it, right? I don't think I have a good answer for that. But maybe the audience can, some of you might have the answer. So I also love to hear that. Yeah. Sorry, Johan, can answer your question to that. Yeah. Thank you.
Hi, I'm Vũ from Utong University, Vietnam. Yeah, thank you very much for your sharing. And I'm really very much appreciate with your project. And I found that the industry gets a very important role in your project. And my question is how to encourage, how to attract them get involved in your project. And another question is how to become the Fat Lab member.
Oh.
Okay? Yeah, thank
So
you.
the first question is that how to
How to adjust
the
the industry gets involved your student project, right?
how to address the
Industry.
industry.
Yeah.
Okay,
Gets involved to your student project. Yeah.
Okay. So what we do is, because the first questions, my answer is that we have been, since we identified the challenge about 2014, we have one of the big strategy in the Singapore Polytechnic we have adopted was the faculties were, well, for the last 1 to 2 years, one dedicated things they have to do outside their normal teaching is to engage the industry. They were organized to go to different companies, talk to them and understand their need and also discuss with them how they may help in our training of our students. That was an extensive exercise happening now. As we speak, we still haven't finished that part of it. So through those engagement, we explore possibility for project with them as well. So multifaceted, that was one. And the second question was joining FedLab, right? Actually, on the website, they are, anybody can join. Yeah, but I mentioned that there are 70 over FedLab that run the academic program where the professor conduct his lesson. That one, I think you need you need him to say, yeah, you can help him to run that program. But if you want to be part of the FedLab globally, I think it's not that difficult. They just have a set of requirements. Yeah, in fact, the FedLab concept started more of an outreach in Boston. And then, if I'm not wrong, the second FedLab was actually outside US, is in Ghana. And then went on, you know, that was some of the history. And, yeah. So it should be quite easy, yeah. But if you do need some help, you can let me know. I can ask my colleagues who are involved in that to help you. Yeah. Thank you. Yeah.
Okay,
Thank you.
Yeah, thank you very much.